Hi guys, Mr. Kane here.
Hi guys, Mrs. Gosswish.
All right, we're ready for the third installment of nomenclature.
There's the type 3?
There is a type 3. We did type 1 and 2 in the first video.
Correct.
Then we added in polyatomics to
Right.
types 1 and 2 in the second video.
It kind of falls under.
The polyatomics technically are part of types 1 and 2. We just
Yeah.
separated it to make it easier so we had time to learn the vocabulary.
Yeah.
Now we got type 3s. Type 3s are called covalent compounds. They're not ionic, which means there will not be ions.
There will not be ions. They are sharing electrons in the bond between the atoms.
Correct.
All right, I remember that.
All right. So it's a different kind of bond. Type 3 compounds contain only nonmetals.
Right-hand side of the periodic table, and sometimes the metalloids.
Sometimes the metalloids, right? But there will be no metals at all.
Right.
Prefixes are needed to denote the number of atoms present. That's because there's multiple ways for nonmetals and metalloids to bond with each other.
Yeah, and if they're not made of ions, then you don't have those charges telling you how many you need.
Because, for instance, there's this, and there's also this.
Yeah.
Those are two very different ratios and two extremely different compounds. These are not ions, like we said. They're elements that form compounds by sharing their valence electrons instead of gaining and losing. And like you said, nonmetals and metalloids, sometimes, and that's an exception. We're not really going to get into that too much.
No. All right, rule for naming the type 3 binary covalent compound. The first element in the formula is named first. Use the full name, which is kind of like...
That's what type 1 did, right?
Yeah, type 1 was the same way. They got their full name.
Okay.
Second element is named with the root and the IDE ending, which
That's
that's kind of the same as the type 1.
Right. That's the same as ionics.
Right. It's just
both type 1 and 2.
I knew there was going to be a trick here.
Here's the difference. Because we could have more than one oxygen, like carbon monoxide and carbon dioxide, because there could be more than one oxygen or more than one of the nonmetal, we have to use prefixes.
Prefixes to denote how many are in the compound.
So we should memorize the prefixes.
Right, which
1,
we've used
2, 3, 4, 5, 6, 7, 8, 9,
and 10.
And 10, right?
Yeah.
Prefix mono is never used for naming the first element.
Well, if the symbol is there, it's pretty evident that there's one of them, so they don't use mono for that one.
Right, but if there's two of the first element, we use di.
Yeah, they use all the other prefixes, just not mono for the first guy, and only the first guy.
Right.
All right. Now, there's a little bit of rules about the grammar revolving around the vowels.
Go ahead and talk about that.
All right, so grammatically, especially revolving around the oxide as the second guy, you don't use AO or OO. Drop the A or the O from the prefix. So it's not monooxide, it's monoxide. Drop the O from mono. It's not tetraoxide, it's tetroxide. You drop the A from the tetra and the penta and the hexa. So grammatically, no AO, no OO. I know it sounds weird to say pentoxide, but there's no A with pent. You drop the A on penta, and it's just pentoxide.
Pentoxide.
Right. But the di is okay. The di and the tri. It is dioxide. It is trioxide. Those are okay.
This is the other way. You'd have to say oxide.
Yeah, I know. It sounds really weird.
Weird.
Yeah.
Right. All right. So some examples here.
All nonmetals.
Yep. Carbons and chlorines, all nonmetals.
So carbon, you don't use mono for the first guy if there's only one.
Carbon.
4 is tetra.
Tetrachloride. Now, technically speaking, Mrs. G, I capitalize all this. These aren't actually necessarily capitalized, right?
No.
Okay. I just tend to capitalize because I do.
We look at them as proper names. And nitrogen. And let's see, di. And the vowel is okay, dioxide. So you're okay.
Take the I off because it's easy to say. It's really
the oxide you have to be careful of.
Oh, so yeah.
Yeah. Iodine. Penta. Fluoride.
Simple, huh?
Oh, ooh, I didn't superscript that or subscript that 5.
We're going to skip that one.
Oh, it has a die though. Come on.
All right, fine. N2O5.
So dinitrogen.
We want nitrogen to die, huh? Dinitrogen.
Dinitrogen. Now here's penta, so you got to be careful. Penta and oxygen. So let's see. Pent oxide.
Right, because it would be harder to say pentaoxide.
Right.
OXIDE. So that's part of that AO or OO.
Yeah, so no AO, no OO.
Right, so we just take it off of the prefix. We don't
yeah.
take it off of the
You
oxygen.
take it off the...
Because we need to still be able to tell it's oxygen.
All right, now going backwards.
Hey, this is, I don't even have to deal with charges here because there's no charges.
Right.
I just look at the prefixes. Since there's no prefix on nitrogen, I only have one. Since mon means one, then I'm only going to have one of the oxygen. So I'm going to have NO.
Yep.
That's my answer. No. Phosphorus, again, there's no mono, so I'm just going to write a capital P. Pentachloride, well, penta means 5.
Right. Yeah.
Chloride is Cl, so I'm going to write down PCl5. Right.
You know, Mr. Kane, that always strikes me about all this? If it wasn't for the polyatomics, every compound on the face of the earth would end with an IGE ending.
Oh, this is true, yeah.
It's those doggone polyatomics.
It's those polyatomics. Everything ends with an IGE.
Throw everything off.